Good morning, folk. Today, what we are going to see is why DevOps. That is what we are going to see in the next few minutes. The industry is going gaga about operations, DevOps, and also no ops. That is all the trend now. We will spend the next few minutes understanding what is this whole DevOps, what caused this DevOps to be evolved, or why are we talking about DevOps today. So that is what our primary agenda for the day, and this is the outline. First, we spend a lot of time on why DevOps, and later what is DevOps, and what is all this CI/CD stuff, and how do I do it, and where do I do it, and all these things you are going to see going forward. So, as I said specifically, the next few minutes is going to focus on the topic number one, why DevOps. Before I go ahead and tell you why, we need to rewind back and understand the problem that caused us to this situation. That is why we have reached to this situation and why how DevOps is going to solve this problem. So typically, industry works or most of the teams or businesses are set up like this. There will be a developer team and there will be an operations team. And both of these teams usually don't work very closely. Both of them are separate usually. And they usually are geographically separated or physically separated, or sometimes they don't even talk to each other because the functionality is different and the management is different. So the developer, what they do is they develop some code and make it into a package and give it to the operations team, and the operations team just deploys it. And both of them don't talk about what is this package, what is the dependency, where should I deploy it, what should be the availability, what should be the resiliency, should I take a backup before deploying, should I configure certain things before deploying. None of those things are exactly configured or spoken with when we are talking about a dev and ops team working together. But keep that aside for a moment. Businesses require new features and changes all the time. What does it mean? So, if you take a business like an e-commerce website, let us say, take an example of Amazon and Alibaba. If one website is launching a new feature, it is almost imperative that the other website also has to launch the same feature as soon as possible. Because if you lose that business for this year, you're not going to get that business for the next year. Think of it like a Christmas sales. You don't get Christmas every day. It's once in a year. So if you have some brand new product or tie-up or some feature that enhances the sale of your business, and you launch that feature immediately and your competitor has to react to it. So in other words, new features, new changes, which brings in more revenue, has to be released all the time. And that is why business requires always new features to stay relevant in the market. But we also know that these features have to be deployed in days or weeks and not months. As I told you, if let us wind back to the Christmas example, Christmas comes once in a year. So if a competitor launches a feature, say in November, and if you're waiting for a month to deliver the new feature, your Christmas is going to get over. You're not even going to be ready for Easter by that time. So sometimes new features that are needed to be deployed into production by days and weeks. So the time that you need to prepare for a feature, plan for it, develop it, and deploy it is dictated by your competitor, by your regulatory authority, or somebody else. It is not always how fast your internal teams can move. It is sometimes decided by external factors also. So today it has come down to days and weeks and not months. That is what we need to remember. The first thing is we need features, and the second thing is we need it in days and not weeks. And finally, the dev's job is to develop these new features. That is what is developer is there for. So for a business, you need a developer to deliver these new features. Where does the operations teams comes in? The operations job is to keep the site stable and fast. That is what most of the operations teams will tell you. My responsibility is to ensure that that website is always up and running and all the people can do access everything. But I would say that is not the job of an operations team. No, keeping the site and stable and fast is not the main purpose of ops team. That is because the ops job is to enable the business. Just by keeping the site and stable, they will say that I cannot introduce a new change because a new change I don't know, I haven't tested it, I haven't performance tested it. It might break my application. But if you're going to keep on stopping new changes or new features, your business is going to be out of relevance and they will not longer exist. So ops job is not exactly to keep the site stable and fast. Rather, it is to keep the business running, and developers' job is also enable the business to deliver new features. So in a way, the mission or objective for these two guys are going to dovetailing to one point, that is to enable the business. That is what we need to take forward from here. So let us talk a little bit about the feature itself. Whenever you're developing a new code or a feature, and what happens is a lot of people will be developing this code. It is not like one person developing the code. Multiple teams will be working. Sometimes these teams will be distributed. Sometimes they will be geographically distributed or physically distributed. Say one team is in Houston, probably not today. Uh, Probably they are in, let us say, California. Another team is in New York. So all this code has to be integrated at the end of the development. So both these code, one guy must be developing the logging page, another guy must be developing the payments page, another person might be developing the inventory management. All these codes and feature has to work together. That is, all of them have to be integrated together for having a working website. So what happens is when you do an integration that spreads over a very long time, it becomes unpredictable because there are certain assumptions team one might have made, and they were developed in a silo, and where team two would have changed those assumptions. They would have said that we no longer use these variables, we just use last name comma first name rather than first name comma last name. So any team trying to pick up the name will have a mismatch there. So integration is always long and an unpredictable process whenever your development happens in a distributed manner. It is not only that, when your integration is long, merging all the code to work together is a difficult process. Say, for example, the big yellow line that you see there at the bottom is your baseline. That is, all the code that is getting created is happening here in this baseline. And each branch that you see, the yellow lines that you climb up, is a different feature or a different product line or some other functionality that a developer is making. So each of them is happening separately, and you finally try to merge all the code to the baseline so that it can be delivered to production. So you are doing this, and then finally it all has to come back to the main line so that it can be delivered to production. But when you do this once in a while, only when all the code is ready, when all the development is done by one feature, then you try to merge it, then you find out the other team has changed something else and it is no longer working. So that's again some rework. So typically, integration after a very long development process is hard, and trying to do manually is even more painstaking. That is because manual resources are not going to be as efficient as doing it automatically, and sometimes these resources who are good at all these features and functionality are going to be very highly skilled, and the amount of effort they are going to spend in integrating is going to be quite costly affair. So try to merge as fast as possible. That is what you need to carry forward from here. So if you're going to keep on developing one product feature for 10 years and then trying to merge it with the main line, by the time the main line, that is that product itself, is no longer viable or no longer required. So merging is always a pain when it is long. And what happens when it is long, or why is it long? Because a lot of bugs will be found out at the end of the test phase only. Whenever I say bug, remember the first name, last name example I gave you, that is also a bug. So they have to go back and rewrite the code so that they pick up the exact first name and second name from the other login page that they are creating. So when you say hello John, instead of hello John, it will be something like John Doe. And when you logged in, it will say hi Joe instead of hi John. So the login page and then the landing page has to work together, and a lot of bugs will be found out at the end of the test phase if your integration is going to be very, very long. So integrate more often, that is the thing. And there is a very interesting curve. The curve here is the time that is at the horizontal section, that is the comprehensiveness of testing, like how many features you are going to test, what are all the different functionality you are going to test. And then at the vertical axis you have the length and complexity of the build. So as when you keep on developing code and your system keeps on increasing, think of something like Facebook, where so many different pieces comes together. You have your activity newsfeed, you have your profile picture changes, you have your likes coming into newsfeed, you have your messenger status changes, all those things. So all this functionality happens in one single window, and you need to test all these features, and all of them has to work. So when your system itself is increases, that is in the y-axis increases, and the test also increases, And after some point in time, the amount of testing you need to do is increasing exponentially. So after some point in time, that you are going to spend a lot of effort rather than developing new features, just testing your existing features only. You're not going to develop new features, because testing for one particular feature, it's going to be a huge effort, and then you're not going to release any new feature. So as the system size increases, the load of the test gets bigger and bigger, and the number of bugs you will find is also going to be really big. So that is the problem of integrating for a very long time, and then when you have a very complex system. This is a very interesting bit of it, because if you are a developer, you will know that you will talk to the client, you will identify some user stories or requirements. Usually the requirements will be written as a user stories. Say for example, customer A will come onto my page, put in my username, password, click on this button, and then they will reach this landing page, which will show them their photo as well as their profile information. So this is a very simple user story. Another user story will be like, my customer will come and select these products. They will be able to filter it by price. They will be able to filter it by nearest delivery location, or they might be able to filter it by the vendor that they are selling, or the color of the product. So this is another user story where the user has multiple choices of selecting the product. So these kind of different features or user stories will come from your client, but the way that people who are listening to the user story will understand it differently. There will be recognition differences. A guy will think that the filtering option will work without logging in, but customer might be thinking that that filtering option will work only after logging in. So it is all very simple things that you need to understand very clearly and write it down, and then go ahead and develop it. For example, if that small login part is missing, then you will not be able to customize it based on the users' previous choices that they have made in the website. So when there is a recognition differences, your code is not going to integrate very well, because you will make one assumption and your other team, which is going to write the filtering algorithm, will make one assumption. And the filtering algorithm, let us say it has designed for only logged in access. And the guy who is designing the web page will not even maintain the cookies or sessions, and he will not try to find out the previous values. So both of this code is not going to work together. So always unexpected recognition of differences of requirements is going to cause a lot of integration problem. So there is another thing that you want to understand. How long does it take for a code to be deployed into production? This is developed for an interactive session. Usually I hear like people say that it takes about a month or 45 days or sometimes 8 weeks or sometimes 6 weeks. As I said in the beginning, if you remember, features have to be released into production every single day or every week. We cannot wait for production for months. So usually what happens in the industry currently is people deliver it for every second week or third week, or sometimes there are some clients who deliver it only once in a month. So these are all the different kinds of problems that we face in the industry, and that is why we are running into the problem of not able to sustain the features requirements from the customer itself, or the businesses are not able to meet the market demand, or competitors are forcing them to make changes, but they are not able to deliver it with their current IT systems, in other words. So as I said, we spoke about this. This lead time is typically about 8 to 10 days or 12 days or 20 days. And whenever you are a business owner, you need to make this smart choice. Sometimes you need to decide how many changes that I can make per day, or how much is the lead time for my changes. Because this is a trade-off. You cannot have one of the other. Because if you choose the lead time has to be as short as possible, then can you create a change which is working functional code without bugs, and can you deploy it? Or if you are going to make sure that your changes are going to be functional and working, your lead time for that change is going to be more. So it is a trade-off between these two variables. That is what pushes the customers or business owners to making some decisions on, say for example, this feature is going to take 20 days to develop, and this next feature, that is feature B, is going to take only 5 days to develop. So what is the revenue that I'm going to get from developing feature A? What is the revenue I'm going to develop from feature B? And can feature B build some components for feature A also? What is the dependencies and all those things? So based on this, only a feature gets developed, and the time also is managed. And remember, we are still talking about conventional architecture. So because all these features are dependent, we are trying to do a waterfall method where one step leads into another step, and then it goes on one by one step. And finally, you do a very long integration and find the defects and then try to deploy it. And after deployment, you're still not sure whether it will work or not in production environments, because dev and ops teams are working together, not working together. They're all separate teams. They don't know what is happening and what is required. So it is not just these two variables. There is one more variable that we need to look at, because anybody who has worked in production will swear by these words. Any change that you cause or any change that you deploy into production is there is a slight possibility that it might cause an outage or some kind of a degradation of performance in the production systems. That is not an absolute guarantee that any production guy will give in the conventional method of deployments. If you go out and talk to any DBA or system admin or any application developer in a waterfall method or a deployment package, conventional deployment delivery, he will say that there is always a certain amount of risk, and most often this risk is it will result in an outage for the business itself. So it is not just that your business owner has to look at these two values, that is deployments of changes and the lead times. He has also has to think of the amount of risk that he will be absorbing by deploying a particular change. So this also is another factor when you're deploying changes into production. And once a code that goes into production after all this trouble, and if it is not working, you are going to see this from your developer in a conventional word. I cannot say this how many times, but I have heard this from so many of the developers. Whenever there is an issue, they say that this is not my code, it is your machine, because I tested it in my laptop, I have tested it in my test environment, but in production it is not working. So that means that you are maintaining the production environment and you go and check the environment itself. It makes a very logical sense for most of the guys who is listening to that kind of an argument, but that is not the case. And most of the times they are very stubborn and staunch and say that it works on my machine, so go ahead and fix it, so don't waste time talking to me. And if you go and talk to as a business owner after listening to your application developer saying all these things and you blindly believe that, and you go and talk to the ops guy, it will ops guy will say something like this: it is not my machines, it is your code that is the problem, because my machine is running up and running, I'm going able to check the operating system, it is performing fine, it is able to run other code that is running already, everything is fine there. So only your code is not working, so that means there's something wrong with your code. Don't come and talk to me that your code, my machine is not working. So both these guys are going to blame each other, in other words, whenever there is an outage, instead of trying to fix the problem together. And believe me, this happens in real world even now, wherever there is a conventional delivery model happens. So what happens is, in the interest of stability, sometimes the service owners or business owners, what they do is they discourage changes itself completely. They say that let us not do this change because the stability of my system will go offline. Or sometimes they say that okay, I can take or absorb some amount of risk. Let us go ahead and deploy this change as soon as possible. So this is the difference, or this is the dilemma most of the business owners have to take care of when they are building a system and they want to go to production. And this is a summary of all the things that we spoke about for the last 15-20 minutes. The developers will be saying that I'm waiting 70% of my time for a new features or a new product or a dev environment to be working. Whereas when you talk to an infrastructure owner or ops team, they will say that I don't have spare capacity to launch new features. Say, for example, sometimes a Pokemon Go is a very nice game. When they launched it, there was a nice article published recently where on the launch date in Australia and New Zealand, they estimated 5 times the growth. Say, let us say there will be 5 customers and they estimated the capacity for 25 customers. But what they got is 50 times the capacity or 50 times extra workload they got. And they had deployed in a container based environment at production and they were able to deploy it. So just give me one moment. And we are talking about multiple people deploying it multiple times per day, and this is how the big guys do that. So Amazon was doing more than 1 second, and Netflix is doing 1,000+ times per day, and Etsy is doing it 50 deployments per day, and Flickr does it about 10 deploys per per day. And finally, you have Facebook, which has almost one deployment. And in fact, this is interesting bit. This is a little bit of old data, 2012 data, but Facebook changes the entire code every single day. That means that they ship about 200 GB of code to all their servers so that every server runs the latest version of the code. So the network bandwidth itself is unimaginable. If you want to deploy 200 GB to 1,000 servers, that is like you're talking about 200 terabytes of data to be moved to all across the world. So just managing the network pipeline for something as big as this itself is an unimaginable feat. So they have engineered it and they have successfully delivering it, and they have done it for the past 5 years. Now I'm sure they must have improved their deployment models to something even better. So if you want it, you have the link at the bottom. You can go ahead and read up more about how Facebook deploys it. There is some very high level article, but it's a very interesting read for each of those deployment cycles. So that was personally very, very surprising and shocking for me. I came from a conventional deployment model where I used to deliver it every 8 weeks. My change lead time used to be at least 15 days, and after 15 days only I can read or deliver any important change to my production. But now it has changed. But when I saw these numbers, when I was preparing for this session, it was really shocking for me. So finally, there is a better way. That is how the dev and ops teams works together. So this is where things starts getting interesting, and where both these teams start working together, in other words. So there are three different models that usually happens. One is you start making the dev and ops team work together. You tell the dev team saying that this is your ops team. You have to tell them what you're going to deploy, when you're going to deploy, and what is going to be the resiliency, what is going to be the backup, which regions you want to deploy. So in other words, you start the communication flowing. You get both the teams working together, and this is one method where there is a smooth collaboration between the dev team and ops team. And it is not only deployment. Sometimes you need to get the feedback from the operations team also and feed it back into the saying that this particular feature that was deployed 10 days back is causing performance leakage or memory leakage on this server. So go ahead and fix it in this application. So you need that feedback from the operations team. So the solution team two is, it's not only having some amount of collaboration, you have embedding of ops team inside your dev team. That is what you see at the bottom. There is a circle there where both the teams work together instead. So both the guys, ops and dev, are integrated into one team and they work fantastically to deliver the product features. Finally, taking this to the next level is where DevOps goes to the next level, where there is a continuous experimentation. You break the team into smaller teams now. Each team has a dev and ops personnel, and they work on different products or features. And all together, they make up the entire product itself. So there will be a product feature team for login. There will be a feature team for payments. There will be a feature team for personnel management, user management. So all of these teams will have an ops personnel also, and they all work together continuously. And there will be a feedback loop, and they will work between the teams also, and combined together they release a product or a feature to the client. So this is where DevOps really excels, where there are small teams and continuously experimenting on new features, releasing new features, and they work together, get the feedback from ops team, and then take the feedback and release a better product next time also. So this is where we move on to why there is a DevOps and what is a DevOps part. To summarize here, we saw that conventional delivery model wastes a lot of time and effort by not delivering on time, and there are a lot of problems without communication. So DevOps is typically, I would say, is a culture where there is a more coordination between the business owner, delivery owner, ops team, developer team, and then your testers and everybody. It is a culture, and you cannot build a culture all of a sudden. You need to make the teams work together. You need to build that culture from ground up, and it is not some tool that you can deploy in your current environment and suddenly you change everything to a DevOps world and all your problems of goes away. So there are certain things we can do to build this culture. For example, the type of collaboration tools that we can use, the type of technology that we can bring in, and some of the problems of DevOps can be solved with technology. So that is what we are going to see. What is DevOps next?